Good morning. I welcome you all to the series of lectures on thermodynamics. Today we are going to discuss about the path function and point function. See what is path function and what is point function. See area under PV curve gives work transfer. We already know. If you draw any curve on PV plot and if you mention that area under the curve, that gives work transfer in that process. Similarly, area under TS temperature entropy curve gives heat transfer. For example, if you draw any process on TS plot, if you draw the area and if you find the area under the curve, that area under the curve gives heat transfer in TS plot. In PV plot, area gives work transfer. In TS plot, area gives heat transfer. It is now, let us consider a system initially at state point 1 and we want to take that system to the final state 2 along many paths. That means it is very easy for us to take the system from state point 1 to state point 2 by following many paths. Here first I take the system from state point 1 to state point 2 by following path A. Later I will take the system, that means it is, for me it is very easy to take the system from state point 1 to state point 2 by following the path B. And it is very easy also for us to take the system from state point 1 to state point 2 by following path C and path D, path E, whatever path you can consider. That means it is possible to take the system from state point 1 to state point 2 along many paths. See, I represented A, B, C paths, but initial and final points are same, which are I indicated these on PV as well as TS plot. Now, area under each curve is different, but the system is moving from state point 1 to state point 2. But the area under each curve represents work transfer in that process. If I consider path A, the work transfer is this much. If I consider path B, this is also included this much. So that means area increased. If I consider path C, this area is also included. That means area increasing. So that means the work transfer is not depending upon the endpoints. It depends on path followed by the system. Area under PV curve gives work transfer. So area in each process is different. So in area under each curve is different. So automatically work transfer in each process is different. So it is a path function. It is not a point function. Similarly, heat. If I take the system from state point 1 to state point 2 by following path A, this is the heat transfer, this much heat. If it is path B, the area is increased this much, so heat transfer increased by an amount of this much. If it is path C, the area increased further this much amount, so heat transfer is also increased this much. So that means heat transfer in each process is different and it is dependent upon the path followed by the system. It is not dependent upon the endpoints. Now, in this case, for this reason, we can say work and heat are called path functions and they are inexact or imperfect differentials. Their inexact differentials are imperfect differentials. Whereas in the case of properties are point functions. They depend on endpoints, not on the path followed by the system. See, properties do not depend upon the path followed by the system. Whatever the path you consider, the change in pressure, for example, the change in pressure in state point 1 to state point 2, even path A, path B or path C, it is only P2 minus P1. It is only T2 minus T1. It is only V2 minus V1. It is only S2 minus S1. So that means properties are, depends on endpoints. So they are called properties of the system and they are not dependent upon the path followed by the system. See, if you see this one, hence properties are exactly differentiable or perfectly differentiable because integral 1 to 2 dv v2 minus v1, integral d 1 to 2 p dp, change in pressure is p2 minus p1, change in temperature is t2 minus t1. But for work and heat, integral 1 to 2 dw, you cannot write w2 minus w1. Change in work is not equal to work at w2, work at state point 2 and difference of work at 2 and work at 1. It is not equal to the difference, but it is delta w is equal to w1 to 2. That means work transfer in process 1 to 2. Maybe path A, maybe path B, maybe path C. You have to indicate that clearly. Or you can write w1 to 2 or w1 to 2 like this. Same for heat also. Integral 1 to 2 dq. You cannot write heat at state point 2 minus heat at state point 1. Unlike properties T2 minus T1, P2 minus P1. But you have to write heat as Q122 or Q122 like this. So that means heat and work are path functions They depends only on path followed by the system, not they do not depend on endpoints. Hence, they are path functions, heat and worker. Thank you very much.